Hello everybody, today we're taking a look at Unit 1, System of Linear Equations. We're going to see the difference between elimination or substitution. Our learning objective is I can set up, solve a system of linear equations using graphing, substitution, and elimination methods. Now the goal here is to take a look at which strategy will work better for which type of situation, using elimination or substitution. So sometimes you get a system of equations and elimination is super easy and you do it that way and you're done quicker. And sometimes it's easier to just use substitution. So not dealing with graphing in this one because you could do that with any system of equation, but kind of just going over these two strategies and when to choose which one, I guess. So let's take a look. So given the following system of linear equations, decide whether to use elimination or substitution to solve, explain your reasoning, and solve. Lastly, come up with an idea of how to decide which strategy is best for different situations. All right. So I have 4 examples here. And just to, I guess, let you know, 2 of them will be eliminations easier, 2 of them will be substitutions easier. But just by looking at them, we don't really know until you kind of think about it. So I'm going to take a look at this first one here. I have 7x plus 2y equals 24. And an 8x plus 2y equals 30. So first off, we want to ask ourselves, is elimination easier or is substitution easier? So when I see these 2 equations, I'm noticing first that they're both in standard form. Your ax plus by equals c. Right? You can see the x's kind of line up here and the y's kind of line up here. And just, some value, some number here. I'm also noticing that I have a 2y in both equations. Okay, so for me, when I see that they're both in standard form and something's in common, this is a perfect situation to do elimination. Okay. Why elimination? Because both in standard form and there's a 2y in both. All right, making this 2y very easy to eliminate that variable and then solve for it later, okay? So let's set up and solve this one. We have 7x plus 2y equals 24, and 8x plus 2y equals 30. All right, and as we've learned, we can take lines, and as long as the variables are lined up, like the x variable is lined up, the y variable is lined up, equals lined up, the numbers lined up, both of them are written in standard form like this. We can subtract this equation from this equation and just subtract right down the line here. So 7x minus 8x, that's going to be negative x, right? Negative 1x. My 2y minus my 2y is 0, right? That's what I noticed up here, that these are the same. So now when I subtract it, 2y minus 2y is 0. So I don't even need to put anything there. That's elimination right there. We eliminated that variable. That is equal to 24 minus 30. So that's a negative 6. So I have learned that negative x is equal to negative 6, which in my mind, I see that as positive x equals positive 6, right? If I multiply by negative 1, I guess you would do. So I learned that x is equal to 6. No, we still need to figure out what y is, so I can plug this x into any of these equations. I'll just choose the top one. So 7x, so 7 times 6, plus 2y equals 24. 7 times 6 is 42. So 42 plus 2y equals 24. Minus the 42 on both sides. Now 2y is equal to, what's that, a negative? Let's always make sure here. Get weird ones. 24 minus 42, negative 18. Negative 18. With 2 times y is negative 18. Sorry, I'm running out of room, so I'm going to be, basically I'll divide by 2 on both sides. And my y is going to be a negative 9. All right. I don't have room to check, but I'll do it on the calculator. Make sure that x is 6, y is 9. And I'll do it by plugging into the second equation here. So 8 times x, which is 6, plus 2 times y, which is negative 9, is equal to 30. So that work checks out. All right, let's take a look at this second equation. 2x minus 3y equals negative 1, and y is equal to x minus 1. Now, what I notice here, different than this one, these were both in standard form. See how everything lines up nicely? This one, not so much. Also, one of these equations is set in y equals, like y equals x minus 1. So I know for this equation right here, this y variable, I could plug this equation into here. This y, I can use this, the x minus 1, and plug it in for that y right there in that equation. This is a perfect example of substitution. All right, I'm going to substitute what y is equal to into this equation. All right, so I'm going to say that y, I'm going to do this, is the y equals x minus 1 can be substituted into line 1. This is line 1 up here. This is line 2. All right. So I'm going to do exactly that. I have 2x minus 3y, but I know y is equal to x minus 1. So I'm going to substitute, instead of 3y, I'm going to go 3 times x minus 1 equals negative 1. All right. Now I'm just dealing with x's, and I can solve this. So 2x minus, I need to distribute, right? This is minus 3 times x, so minus 3x, minus 3 times negative 1 is, actually turns that into a positive 3, all right? Because a negative times a negative will make that a positive. That is equal to negative 1 still. 2x minus 3x. This is negative x, right? These two combining like terms. Plus 3 equals negative 1. Now I need to get rid of this 3 here, so subtract 3. I'm left with negative x equals negative 4, which means x equal to 4. Very good. Halfway there. Always look back at your equation. What's the easier one to plug this number into, and you'll solve for the other one. Since y is equal to x minus 1, I'm just going to plug that 4 in for x here, and it'll tell me what y is, right? So y is equal to x minus 1. We know this is a true statement. It says so right here. X is equal to 4, so I'm just going to plug in my 4 for x minus 1. So y is equal to 4 minus 1 is 3. Right on. let's check this real quick. Let's check it on the first line. So 2x, so 2 times 4 minus 3 times 3 is -1. There we go, right on. All right, so that was a substitution. Let's take a look at the third one. We have x is equal to -3y plus 5 and -4x plus 5y equals -3. So let's take a look. Is this elimination or substitution? When I see this, again, I see the variables, even though they line up, see the x's kind of line up, the y's kind of line up, and the number out here lines up, but the equal sign is not really lined up, right? This is in standard form, right? We have ax plus by equals c, but this is not in standard form. This is x equals -3y plus 5. This is more of a substitution method because I know what x is. X is equal to this equation right here. So I can plug this in for my x down here. I can substitute this line here into this line here. All right. So another good example of substitution. So my x can be substituted into line 2, right? My x equal to, I know what x is, so I just take this whole thing and put it into the x down there. Then I'm only dealing with the y's. All right, so that's what I'm going to do here. So I'm going to be putting this equation in for the x down here. So I'm going to start with the -4 times my x variable, which is -3y plus 5, plus 5y equals -3. Okay, so I just took this second line and substituted what x is equal to into it, right? Now we have to do a little bit of math here to solve, little distribution, right? -4 times -3 makes it positive 12x. -4 times positive 5 makes our negative minus 20. The 5y stays the same, equals -3. This is, sorry, I made a little bit of a mistake. This is supposed to be a y, -3y plus 5 makes that a y as well. I notice I had x and y. Should be all y's there. All right, so 12y minus 20 plus 5y equals -3. We need to combine our like terms here. So 12y plus 5y is 17y, right? I'm going to circle our like terms in this situation. There's combining those. All right. And I'll do the next on the next step. So 17y minus 20 equals -3. Now I'm going to add 20 to both sides, right? Because I got to get rid of that. Plus 20 plus 20. So 17y is equal to -3 plus 20. That is 17. So 17y is equal to 17, which means y is equal to 1. Now let's plug that into one of our equations and figure out what x is equal to. It's telling me here x is equal to -3y plus 5. So that's probably the easier one to figure out what x is equal to, right? So because x is equal to -3 times y, which is 1, times 1 plus 5. So x is equal to -3 times 1 is -3 plus 5. X is equal to 2. Yes? Let's check. Let's plug these into the second equation, make sure. So -4 times x is 2 plus 5 times 1. That's equal to -3. So we win again. All right, let's do the last one, and then let's summarize. So 5x plus y is 9. 10x minus 7y equals negative 18. When I see this, I notice that my x variables lined up, y variables lined up, numbers lined up, equals is lined up. I don't have anything in common as far as our variables, like our 5x and 10x isn't the same. 1y, negative 7y. Those aren't the same, but what we can do, as we've learned, we can manipulate one of these equations to make them the same in order to use elimination. So I'm going to use elimination because they're both in standard form. Both standard form. Okay? And I see 5x and I see 10x. When I see numbers that can like easily be multiplied or kind of manipulated to make it equal to another one, so I get something in common, that kind of like sets a light bulb off in my head. So I can multiply, so I can go times 2 to line 1 so that I'll make this a 10x and that'll be a 10x. Okay, so we're going to go multiply this line times 2 so that we have something in common. Okay, and I'll do that work down here. So I'm going to go 2 times 5x plus y is equal to 2 times 9, right? Notice I just multiplied both sides of the equal here times 2. All right. Now when I distribute the 2, this is going to turn into 10x plus 2y equals to 18. Basically, I'm just doubling everything in this equation, and it still makes everything true. But what it did for me is now I have 10x in both equations, okay? So now I'm going to rewrite line 2 underneath that, my new line 1, minus 7y equals negative 18. Ooh. Now I have 10x and 10x, okay? Now I can subtract. So 10x minus 10x becomes 0. This is gone. 2y minus 7y. That's like subtracting a negative, so I better check on that. 2y minus a negative 7. That's a positive 9. Remember, like subtracting a negative number makes it a positive. So this becomes 9y is equal to, again, we have 18 minus a negative 18. This is like a double negative situation. Don't think that's 0 because you are subtracting. Minus negative 18. 36. All right. Always check your stuff with the calculator. Even though it may look like you might see this, see 18 minus 18, 0. But remember, it's 18 minus negative 18. All right. So since 9y is equal to 36, divide by 9 on both sides. 36 divided by 9 is 4. So y is equal to 4 here. All right. So let's now figure out what x is. Let's use line 1 here because I just have the single y here. So 5x plus y is equal to 9, and we know that y is equal to 4. So 5x plus y, and y is equal to 4, is equal to 9. I need to subtract the 4. Tells me 5x is equal to 9 minus 4 is 5. 5x is equal to 5, then we know that x is equal to 1. Fantastic. Always check. Let's check on line 2 here. 10 times 1 minus 7 times 4 is negative 18. That is good. I'm going to check line 1 as well, just for fun. So 5 times 1 plus 4 is our 9. So that is absolutely correct. Always check both both lines. So let's wrap this up. I know this video has been long. When is it easier to use elimination? When is it easier to use substitution? So let's look at our elimination ones. For both elimination examples, we had both equations were in standard form, and in this case, we were able to eliminate the 2y right away. This one, it took us timesing it by 2 to get something in common there. But this kind of moral of the story is both of them in standard form, and it's very easy to get something in common. Like in this case, we made these 10 x's in common. In this one, we were already given the 2y in common. But, so when is it easier to use elimination? I'm going to say both in standard form. Okay, and it's easy to eliminate a variable by finding something in common. So like in this case, we were able to make 10x in both equations. In this case, we were able to make 2y in both equations. Say easy to make something in common. To eliminate a variable. All right. When is it easier to use substitution? Now in the substitution, we didn't have both of them in standard form. Notice both of them were not in standard form. One was just like a y equals, and the other one was an x equals. So when one's like a y equals, look, you can just plug that y equals in, you can just use substitution. Just substitute that into the other equation. Same thing here, x is equal to this, so just use what x is equal to and substitute it into this equation here. So when's it easier to use substitution? You could say one equation is either y equals or x equals, right? Because we have a y equals here and an x equals here. When you have something like that, just substitute that into the other equation. Substitute into other equation. All right. So hopefully that helps figure out when you're given a system of equations, whether or not you use elimination, or is it better to use substitution. All right. Thank you very much. Bye-bye.